Hello everyone, this is Mark Joseph
This is Raymond.
And this is RG.
And this is Mirjun.
and we are Math Students.
Hello everyone, my name is Mark Joseph Ibampag and I am your first presenter for this day. Today I am going to discuss under the subject of number theory, which is Euclidean algorithm. So first, what is Euclidean algorithm? In mathematics, the Euclidean algorithm or Euclid's algorithm is efficient method for computing the greatest common divisor of two integers, the largest numbers that divides them both without a remainder. So the definition of common divisor, a positive integer f is said to be a common divisor of a and b if and only if divides A and F divides B. So the greatest common divisor or the GCD of A and B is the positive integer D denoted by D or the GCD of A and B, satisfying the two theorem. D divides A, D divides B, and second, if F divides A and F divides B, then F is less than or equal to D. So we have an example. The GCD of 18 and 12 is 6. So when we factor the positive integers of 18 is 1, 2, 3, 6, 9, and 18. And 12 is 1, 2, 3, 4, 6, and 12. So the greatest common divisors is 6. So check the properties. So 6 is divides 18. Yes, because 18 divides 6 is equal to 3. And 6 divides 12. Yes, also, because 12 divided by 6 is 2. And the second is 2. 2 divides 18. Yes, also, because 18 divides 2 divided by 2 is 9. And 2 divides 12 or 3 divides 18 and 3 divides 12. Yes, because they are visible to 18 and 12. So if A and B is defined, the GCD of A and B is equal to negative A, B is equal to A, negative B.
Good day, everyone. I am RG Salvadico. I am the second presenter. This is the continuation of our topic. So let's continue. All about Euclidean algorithm. Given two integers a and b, where a is greater than 0. Repeating the application of division of algorithm, we obtain a series of equations. B is equals to aq sub 1 plus r sub 1, where r sub 1 is greater than 0 but less than a. A is equals to r sub 1 u sub 2 plus r sub 2, where r sub 2 is greater than 0 but less than r sub 1. R sub 1 is equals to r sub 2 u sub 2 plus r sub 3, where r sub 3 is greater than 0 but less than r sub 2. R sub n minus 2 is equals to r sub n minus 1 u sub n plus r, where r sub n is greater than 0 but less than r sub n minus 1. R sub n minus 1 is equals to r sub n u sub n plus 1. Then, the last non-zero remainder, r sub n, in the division process is the greatest common divisor of a and b. Then, r sub n is equals to quantity a and b. Example, find the GCD of 68 and 328. So here is the solution. Let a is equals to 68 and b is equals to 328. So here are the formula. Here is the formula. B is equals to aq plus r. So 128 divided by 68 is 4 and the remainder is 56. 68 divided by 56 is 1 and the remainder is 12. 56 divided by 12 is 4 and the remainder is 8. 12 divided by 8 is 1 and the remainder is 4. So 8 is equal to 4 times 2 is plus 0.
So, hello everyone, my name is Merton Swatting and I am your third presenter. So, this is our continuation of our topic. The less than zero or digit remainder gives the GCD of 68 and 328. Thus, 68 and 328 is equals to 4, that is our GCD. So let's solve for our theorem. Let A and B elements of all integers such that A and B is defined, then there exists X and Y element of all integers such that A and B is equals to A sub 0 plus Y sub 0. To obtain the integral values of X sub 0 and Y sub 0 such that A x sub 0 plus y sub 0 is equals to t is one important use of Euclidean algorithm. To obtain the integral values of x sub 0 and y sub 0 such that a x sub 0 plus y sub 0 is equals to d, we consider the backward substitution eliminating terminators. So 4 is equals to 12, and our term have an imaginary number 1 minus 8 times 1. So we substitute the value of 8, so it's equals to 12 minus the value of 8, which is 56, minus 12 times 4 is equals to 12 times 5 minus 56. So we substitute the value of 12 is equals to 68 minus 56 times 1 times 5 minus 56. So is equals to 68 times 5 minus 56. So we substitute the value of 56, which is equals to 68 times 5 minus the value of 56, which is 328 minus 68 times 4 times 6 is equals to 68 times 29 minus 228 times 6. Note that x sub 0 and y sub 0 is equals to 68 and 328. X sub 0 is equals to 29 and y sub 0 is equals to negative 6. So 68 times 29 plus 328 times minus 6 is equals to 4.
Good day. I am Raymond Jan Sobradilla, your last presenter for this topic. So here is the continuation of our report. Theorem. If B is equal to AQ plus R, then the GCD of A and B is equal to the GCD of A and R. Illustrations. A. 34 over 5 equals 6 plus 4 over 5, or 34 is equal to 5 times 6 plus 4. Then the result will be the GCD of 5 and 34 equals to the GCD of 5 and 4. Then the result is 1. B. 22 over 4 is equal to 5 plus 3 over 4, or 32 is equal to 4 times 5 plus 2. Then the result will be the GCD of 4 and 22, then equals to 4 and 2, then the GCD is 2. And thank you for listening. That's all.